This video was brought to you today by Aclass Tutors. Let the fun begin! Hello my beautiful bright stars! Today we are looking at number theory, specifically properties of numbers. Now if you have not seen our first video on properties of numbers, please pause this video now and check out the link at the bottom of your screen. What does commitment mean to you? Commitment for me means deciding to do something no matter what the results are. Deciding to do something even when you don't feel like getting it done. Commitment is the difference between those who live their dreams and those who dream about their dreams. What dream do you have that you want to bring into reality? What dream do you have that you would like to manifest in this physical form? Let me tell you something. Your dream is possible. You deserve the greatness that life has in store for you. But sweethearts, you have to be committed. You have to decide, hey, I am going to do this. I am going to get this done because I deserve my dream. Your dream is possible. I believe in you. Do you believe in yourself? The additive identity. What can we add 5 to that will give us a result of 5? How about this example? What number can we add 19 to that will give us a result of 19? If you said 0 in both cases, you are correct. 0 plus 5 is equal to 5. And 19 plus 0 is equal to 19. 0 is said to be the additive identity, and this is because 0 plus any number gives you back that number. The multiplicative identity. Can you think of any number we can multiply 5 by that will give us a result of 5? How about this example? Is there any number we can multiply 6 by that will give us a result of 6? If you said 1 in both cases, you are correct. 1 multiplied by 5 is equal to 5, and 6 multiplied by 1 is equal to 6. 1 is called the multiplicative identity, and that's because 1 multiplied by any number gives you back that number. The inverse of numbers under addition. Let's look at 45. Do you think you can do anything to 45 under addition that can make it 0? How about negative 12? Is there anything we can do to negative 12 under addition that can make it equal to 0? If you said 45 and you're minusing 45, you're correct. If I say 45 minus 45, I'll get 0. In the case of negative 12 plus 12 gives me 0. And 0, remember what 0 is. 0 is our additive identity. So every number added to their inverse gives you 0. To find the inverse of a number, all you have to do under addition is change the sign of the number. The inverse of numbers under multiplication. Now let's look at this one. We have 2 equal 1. Now what can we do to 2 that will give you an answer equal to 1? And how about this one? Negative 9 equal 1. Is there anything we can do to negative 9 under multiplication that will give us an answer of 1? If you said in the first case, I can multiply it by a half, you are correct. 2 times a half is equal to 1. And if I say negative 1 over 9 multiplied by negative 9 is equal to 1, again, you're correct. So, under multiplication, the inverse is simply found by inverting the number. The concept of closure. 3 plus 4 is equal to 7. 3 and 4 belong to the set of whole numbers, and their result gives you a number that also belongs to the set of whole numbers. The set of whole numbers is therefore closed under the addition of numbers. How about this one? 6 multiplied by 8 is equal to 48. 6 and 8 belong to the set of whole numbers. And 48, their result, is a whole number as well. So what we can say is that the set of whole numbers is closed under multiplication of numbers. Let's look at this example. 5 plus 7 is equal to 12. If we consider the set of odd numbers, 5 and 7 belong to the set of odd numbers. However, their result is equal to 12, which is an even number. So we can say that the set of odd numbers is not closed under addition of numbers. The commutative law. 2 plus 3 is equal to 5. Let's flip that around. 3 plus 2 is equal to 5. We got the exact same answer. This is because addition is commutative, meaning the order of the numbers does not matter. Let's try another one. 4 multiplied by 6 is equal to 24. And if we flip it, 6 multiplied by 4 is equal to 24. The answer is the same again. And this is because multiplication is commutative. The order of the numbers does not matter. You'll always get the same answer. Let's try this one. 5 subtract 3 is equal to 2. 3 subtract 5 is equal to negative 2. Do you see that our answers are not the same? And that's because subtraction is not commutative. The order of the numbers do matter. Let's look at another example. 14 divided by 2 is equal to 7. 2 divided by 14 is equal to 1 over 7. Do you see that the answers are not the same? And this is because division is not commutative, because the order of the numbers do matter. The associative law. I have 6 plus 4 plus 9. The associative law deals with the grouping of numbers. Let's group 6 and 4. Now 6 add 4 gives you 10, and 10 add 9 gives you 19. Let's try this again. This time, let's group 4 and 9. So we have 6 plus 4 plus 9 in brackets. So 4 plus 9 gives us 13. So 6 plus 13 is equal to 19. Do you see that our answers are the same? I'm sure you did. So therefore, what can we say about addition? Addition of numbers is said to be associative. Let's try this example. 5 multiplied by 3 multiplied by 10. Let's group our 5 and our 3. 5 times 3 gives you 15. 15 times 10 is equal to 150. Let's try that again. This time, let's group the 3 and the 10. So 3 times 10 gives us 30. So 5 times 30 is equal to 150. Do you see that our answers are exactly the same? And that's because the multiplication of numbers is said to be associative. It does not matter how we group them. Let's look at this example. 9 minus 2 minus 5. Let's group the 9 and the 2. 9 minus 2 will give us 7, and 7 minus 5 is equal to 2. Let's try this again. This time, let's group our 2 and our 5. So we'll have 2 minus 5, which will give us negative 3. So 9 minus negative 3 is equal to 9 plus 3, which is equal to 12. Remember, when the signs are the same, we get an addition sign. So 9 plus 3 is equal to 12. Do you see that the answers are completely different? Yeah, they are, and that's because subtraction of numbers is not associative. Let's look at this example. 100 divided by 5 divided by 2. Now, let's group a 100 and a 5. Now, 100 divided by 5 will give us an answer of 20. 20 divided by 2 is equal to 10. Let's try this again. This time, let's group a 5 and our 2. So we'd say 5 divided by 2, that will give us 2.5. So 100 divided by 2.5, that's equal to 40. Do you see that our answers are completely different? And that's because the division of numbers is not associative. The distributive law. When you think of the distributive law, think of it as spreading or the removing of brackets. Now, in this case, we have 4 multiplied by 5 plus 6 in brackets. This can be worked out 2 ways. The first way is we work out what's in brackets first. So we'd get 4 times 5 plus 6. 5 plus 6 is 11. So you'd have 4 times 11, which gives you an answer of 44. Another way this can be done is using the distributive law, which simply states that 4 multiplied by 5 plus 4 multiplied by 6. So we have 4 times 5, which gives us 20, and 4 times 6, which gives us 24. When we add them, we get 44, the exact same answer. And this is because multiplication is distributive over the addition of numbers. Let's look at another example. We have 6 multiplied by 10 minus 3 in brackets. The first way we can do it is compute what's in brackets first. So we'll get 6 times 10 minus 3 gives us 7, so we get 6 times 7 is equal to 42. Now let's try using the distributive law. We'll say 6 multiplied by 10 and 6 multiplied by 3. So we have a minus sign and 6 multiplied by 3. 6 times 10 gives us 60, and 6 times 3 gives us 18. 60 minus 18 is equal to 42. Do you see that we got the exact same answer? And that is because multiplication is distributive over the subtraction of numbers. The fundamental theorem of arithmetic. The fundamental theorem of arithmetic simply states that all composite numbers can be expressed as the product of its prime factors. Do you remember what a composite number is? A composite number is all those numbers that have more than 2 factors. Now, what is a prime factor of a number? Now, the prime factor of a number is a number that, first of all, it has to be a factor of that number, and secondly, it must be a prime number. Do you remember what your prime numbers are? Let's refresh your memory. Now, your prime numbers are all those numbers that have only 2 factors. Do you remember what a composite number is? A composite number is all those numbers that have more than 2 factors. Now, what is a prime factor of a number? Now, the prime factor of a number is a number that, first of all, it has to be a factor of that number, and secondly, it must be a prime number. Do you remember what your prime numbers are? Let's refresh your memory. Now, your prime numbers are all those numbers that have only 2 factors. And they are 2, 3, 5, 7, 11, 13, 17, 19, 29, all the way to infinity. So let's look at how we can find out or express a number in terms of its product of its prime factors. Let's use this example. We have 50. The first thing you do is you select a prime number in our list that can go into our number. Usually you start with the lowest prime number, in this case 2. So 2 can go into 50 how many times? 2 can go into 50 25 times. Can we use 2 again? No, because 2 cannot go into 25, and neither can 3. So therefore we move on to the next one, which is 5. So 5 into 25 gives us 5. We can use 5 again, because 5 can go into 5. 5 into 5 gives you an answer of 1. We are basically reducing the number to 1. So therefore, 50 can be expressed as 2 times 5 times 5, which gives you a product of 50. So do you see that a number can be expressed as a product of its prime factors? I'm sure you do. We've reached the summary. The additive identity is 0. The multiplicative identity. The multiplicative identity is 1. The inverse of a number under addition. The inverse of a number under addition is obtained by simply changing the sign of the number. The inverse of a number under multiplication is obtained by inverting the number. A set is said to be closed under an operation if when the operation is performed, the result is a number within the set. An operation is said to be commutative if the order of the numbers does not matter. An operation is associative if the way in which the numbers are grouped does not matter. Multiplication is said to be distributive over addition and subtraction. The fundamental theorem of arithmetic. The fundamental theorem of arithmetic simply states that every composite number can be expressed as a product of its prime factors. That's pretty much it, my beautiful bright stars. Thank you so much for watching. Before I go, I'd like to leave you with this positive message. You were born to live a great life. Step into your greatness today. That dream that you have, know that it is possible. Commit to making your dream a reality. You are going to meet challenges along the way. With every challenge that you face, say to yourself, I can do this. And trust me when I say you can.